Yes, dear students, in this video I will discuss the electric potential due to dipole. Due to dipole. Number one, at any point in axis. Here in this figure, Q charge minus Q charge, Q charge minus Q charge are placed at point A and B, separated by distance 2a. Point P lies on axis. Point P lies on axis at distance r from center. And we know electric field due to point charge to a distance r. 1 upon 4 pi epsilon 0 q upon r. Now remember electric field also at point 1 upon 4 pi epsilon 0 q upon r square. It is 1 upon r and it is 1 upon r square. If we plot a graph between E and R and V and R on same graph, we get a curve. We'll discuss later on, but now I have to use this formula. So in figure, you can describe easily plus Q charge minus Q charge form dipole separated distance 2a and P is any point at distance r. Now electric potential at point P due to plus Q charge. V1 equal to 1 upon 4 pi epsilon 0 Q upon R minus A. Why R minus A? Actually, R distance this way, this is A only. So, AP is the distance of point P from charge Q. Similarly, potential due to potential at P, potential at point P due to minus Q charge, and with that V2 is equal to 1 upon 4 pi epsilon 0 minus Q upon R plus A. R plus A. I think you are easily understanding this topic. 1 year there was question in board exam. Derive expression for electric potential due to dipole on axis. My colleague said, sir, paper has come very simple. I asked him, okay, you go. I was superintendent of the exam. I asked, go and see. I hope this is my guess that student might be deriving formula for electric field on due dipole, and same thing happened. When we checked the copies, we found that instead of potential, student were deriving electric field. Please listen and read the question carefully. Generally, when dipole comes, students start thinking now simply it is asking electric field, but he was asking potential. So total potential at P, total potential at P, V equal to V1 plus V2. So simple question is this: Q upon 4 pi epsilon 0 common 1 upon R minus A minus 1 upon R plus A. Physics involved actually has been applied here and here. Now it is simple mathematics which you need to obtain the result. So now what is LCM here? Q upon 4 pi epsilon 0, it is R minus A square. It will come R plus A minus R or plus A. So thing left here 1 upon 4 pi epsilon 0 2a into q. You can say 2a into q upon r square minus a square. But you know 2aq is equal to p magnitude of dipole moment. I told you potential scalar quantity. So you add scalarly, and so V equal to here come out 1 upon 4 pi epsilon 0 or P upon R square minus A square. It is the potential due to dipole at any point on axis. And remember, point on axis means outside the dipole. You can take point P here also. Now you will get the same result. So for a far point, if R much greater than A, you can be asked write potential due to dipole at far point on axis. तो वो क्या होगा? V equal to 1 upon 4 pi epsilon 0 P upon R square. And they generally ask how does potential electric potential depend due to dipole on distance R at a far point. So you have to write 1 upon R square. Dependence of potential at far point on axis. It is 1 upon R square, inversely proportional to R square. Yes, I was telling if we plot a graph between R, E and V, shown, and we take distance like 0.5 meter, 1.0 meter, 1.5 meter, and 2 meter and 2.5 meter like this. So what type of graph do you expect? E is equal to 1 upon 4 pi epsilon 0 Q upon R square, and V equal to 1 upon 4 pi epsilon 0 Q by R. If R less than 1, suppose 0.5 meter, which will be greater? E will be greater than V. E will be greater than V, and at R equal to meter, both will be same. So we can plot this graph like this. Suppose it comes for V. So for E, then how for V? Here they are equal. At distance less than R, E greater than V. So this graph will be coming like this. Sorry. And then this. This is for V. This is for E. At distance less than R, 1.5, E greater than V. A symbolic diagram. You may be asked to draw this like this. Anyhow, potential due to dipole on axis at far point V equal to 1 upon 4 pi P upon R cube. P is 2aq, dipole moment. If R in meter, it is in coulomb meter, and it is V9 to 10 to the power 9 P upon R square. So V will be in volt. This is a simple case. Now, second point is there. Potential due to dipole at any point in equatorial plane, or potential potential of dipole, potential due to dipole at right bisector of axis or equatorial plane. Equatorial word है, equatorial plane. Why the idea of plane is there? Actually, dipole dipole has two charges, plus q minus q, and right bisector you can think. If it is minus q, it is plus q. Right bisector is this, or this also, or this also. a plane which bisects the axis of dipole is called equatorial plane, and we want to find out potential due to this minus q charge plus q charge. This is midpoint O, point here at distance r. This is 2a, and this point A, this is B. This is center O. This is P, B, and this is P, A. This is A, this is A. Because this point lies on right direction, so PQ, PA is equal to PB भी होगा, और ये अंडर रूट आर स्क्वायर प्लस ए स्क्वायर. दिस इज आल्सो अंडर रूट आर स्क्वायर प्लस ए स्क्वायर फ्रॉम पाइथागोरस थ्योरम. तो पोटेंशियल एट पी, potential at P due to plus Q V1 equal to 1 upon 4 pi epsilon 0 Q upon AP means under root R square plus A square. Similarly, potential due to minus Q, potential due to minus Q, V2 is equal to 1 upon 4 pi epsilon 0 minus Q upon PB, which is also R square plus A square square root. So total potential V equal to V1 plus V2. It is Q upon 4 pi epsilon 0 1 upon under root R square plus A square or minus 1 upon under root R square plus, and it is 0. At every point of the dipole, plane of equatorial plane, at any point of equatorial plane or right bisector, field potential 0. आप इस लाइन पर यानी कि इस प्लेन में कहीं भी होंगे, wherever you are, potential due to dipole is 0. You can imagine your room. At top corner here we have plus q charge, and at same depth we have minus q charge. Then electric potential in the floor at every point of floor is 0. Otherwise you can say like this also, in terms of x, y, z axis. If we draw here x, y, z axis, x, y and z axis. Here is plus q charge, there is minus q charge. So here x, y plane, XY plane will be right bisect dipole. तो in this plane where point here P है या यहाँ A है यहाँ B है कहीं भी, potential is 0. Here it is 0. है भाई. Or if you think this is x, x, y, z, at every point of y, z plane also field is potential 0. So any point which lies in the plane which bisects the axis of dipole perpendicularly, potential is 0. Okay, please remember it. And hence, if we move a point charge from P on this line, no work done. One thing more here, which is important for question point of view. They ask you, it is dipole here, plus Q minus Q. This is O, center O. So give the location where potential 0 but field is there. At every point on equatorial plane, at every point in equatorial plane, potential is 0 but field is there. But students get confused here, what is the electric field at this point O? Many times they write answer 0. Electric field E. Actually, electric field is different from potential because electric field is vector quantity. Electric field due to point charge Q will be in this direction because electric field is a force on unit positive charge. If you plus 1 coulomb charge will repel, it will be attracted. So here field is not 0, field will be here 1 upon 4 pi epsilon 0 Q upon A square due to this one. The same is this one, so 2. I have discussed it earlier also. I keep on discussing this because student do it wrong. Even once when it in the paper, my colleague said, "Oh, what is this answer? It is 0 here." And direction of this E will be opposite dipole moment this way, electric this way. At every point in equatorial plane, electric field is anti-parallel to dipole moment. Please remember it. What I said, at every point in equatorial plane, electric field due to dipole is anti-parallel to dipole moment, and electric field is parallel to dipole moment at every point on axis of dipole, except midpoint. So this was electric potential due to dipole at axis and at bisector. Now there is one more point which is generally asked in competitive exam. Directly answer हो जाता है, electric potential at any far point. I will take it in next video because it will be lengthy. Thank you.